Welcome to CVR Rocket, and in this video we are going to see about we are having qubit entanglement. Actually what happens, like the qubit, the bit, can actually oscillate in any direction in the space. So it has any orientation, left, right, top, bottom, any orientation. We can't define it as left, right and top, bottom, any orientation. So based on that we can decide the predecessor, like we can decide its predecessor position. So if you are focusing, like as I said, reflector example, anything, if you are focusing on one qubit, if we get the information or output of that qubit, so we can simply get the information of its predecessor by just interconnection, because they are having some interconnection. So we can actually get the information of its predecessor. Like if we say we have a bit, a qubit and b qubit, we are focusing on a qubit, so these are interconnected to b, so we can get the information of b, interconnection to b, so we can indirectly inherit the information of b by just focusing on it. So if we apply this for huge combination, so we are getting a lot of information at least by not focusing on it. So it reduces our time, enhancing the speed. So this is what the qubit entanglement. And again, other example or application, sub application is qubit manipulation.
So as you can see in qubit entanglement, as we can see, we have A and B. So if we are focusing on A, some methods like polarization and again some methods. So if we are focusing and gathering the information of A and B are interconnected by these two methods or ways, so that we can also indirectly get the information of B. So that is the actually whole logic of qubit entanglement. Now coming to qubit manipulation. It's like gates, as in for logic gates we are using for bits, so we can use quantum gates. As you can see, these are AND gate, NAND gate, OR gate, exclusive OR, some gates. So we are giving some input 1 0 0 1 0 0 0 1 1 1 0 0 0 0 1 1, etc. So what eventually happens is, like you give any input, you will be getting output, single output, because it's not instantaneous, it is decisive. So whatever the output comes will be dependent on input, so we will be getting single input. The same way you can take for like quantum gates, the other picture here. So in this quantum gate what happens is, so we are giving input qubits, we are getting output which is not decisive. We can't determine it actually, because we don't know the actual values of input. So these are all instantaneously, we are getting all the three values at the same time. Instantaneously we are getting all those values. That is what the quantum gates and qubit manipulation is all about. It can be 0 1 qubits, and output based on the input, it can be anything. Actually it can be 0 or 1 in terms of qubits. So you can see, like if we give unpolarized, like vertical and horizontal disturbance wave, we will be getting either vertical or horizontal, or both will be getting actually as output. So it's not decisive, so we can't determine like what we are getting. It's not dependent, it's actually dependent on the input, but we can't figure out what input is actually. So we are getting all those information at the same time, so that is like instantaneously, so which saves time and increases speed. So that's what the advantage of quantum or qubit entanglement and qubit manipulation. The same thing can be represented by that graph, space graphs. The wave is somewhere in the space, so we'll be getting the same thing as output if we are giving input this thing. So it's like unpolarized thing and passing through separator of, you can say like focusing, which I have said earlier. Like if we are just allowing to pass one state, disallowing to pass the other state, and determining the output actually. So that's like focusing. Now coming to quantum computing, how it works, like now I said the qubits will be passed. Actually in normal computing, traditional computers, what we do, the transistors which are made up of semiconductors are used to make logic gates. So many transistors are used and logic gates are built, like combination of transistor used to build logic gates, and combination of logic gates are used to build like adder modules, etc. And now this combination will help you build a total computer chipset, so that the computer can be possible. The same thing now, the qubits are actually disposed from the origin, and now they're traveling, and they will travel from quantum gate, as you can see in this quantum computing flow diagram. And from there, quantum entanglement and quantum manipulation takes place to give you the resultant result. So a group of these, like if we compute this to be one segment, and group of these segments like take some other segments, this will be performing instantaneously, so we will be getting the results instantaneous. So it's not depending on, like, we are not dependent on output. Actually, we will be getting output input at the same time instantaneously. So this all the segments, the group of these segments will help computing, actually quantum computing possible. And now, as you can see, we are using some inputs, like any input in qubit information, we will be getting output for particular input instantaneous, though it be instantaneous, but we will be getting the final output. That is important actually. So we don't know that that output is correct or not. That input output can be wrong. It's probable case, so we are not sure about that. So for double checking and for removing the duplication, so quantum computing helps us by far. How? By this quantum qubit entanglement and qubit manipulation, we can do double checking actually. And this is represented in this pictorial representation above. So whatever the input we are sending, we will be getting output, and this can be tangled like in groups. So it can be joined in one group, and result will be the same for that group, and the other result will be the same for the other group. So this can be used, and we can use the qubit entanglement actually to determine the information about its predecessor, so it will be fast enough, lessening the time and giving you faster efficiencies and faster speeds to find out the information quickly by using this qubit entanglement and qubit manipulation, because we are getting all the results at the same time, and we can store a lot of information actually, as like as bits are used to store information. Like 2 bits gives the information about the numerical data, we can get the digit, and like for example 8 bits is used to represent a character or string. So what happens, like these are stored, so in this information we will using these bits, all the computing process has been taking place, like semiconductor transistor to logic gates to adder modules to the chip. All this information takes place, and we will be getting the final method or result using these bits. So bits are used to denote or display the information. So now, if these bits can be also used to show the image using the pixel technology. One pixel, like owning and off, using the bits, we can actually toggle around with the pixels, so that this pixel from this dimension should be on now, so that the image will be formed on the display screens. And again, this can be used in video technology, so we will be using the frames per second concept. So many frames will be launching at per second rate, so the video plays. So this how, like, the base is bits only actually for all of these things. And again, if we are using some 4 inputs for the bits, so how much information we can store? So we have so many combinations, so we have 2 power 4 combinations, so 16 combination. In those, only one we can use at a time. So in normal traditional computer, we are using bits, so we will be getting one combination only, so that we will be having one set of information itself. But in this quantum computing, we can use the 2 power 416 number of bits, and the result can be any of 16. It's because it is instantaneous, and it doesn't depend on the it does depend on the input and output, which we are getting at the same time as a final result. So the result can be any of those 16, whereas in traditional computers it is actually one only. So because of this vast criteria of, like, probable condition of any of the 16, quantum computing helps us to store a lot of information and gather some speed and lessen the time and increases our efficiency using this combination of the concepts qubit entanglement, qubit manipulation. So precisely whenever we are using some input like 1100, so we'll be getting output actually for that, and we are not sure about that, is it correct or not, we will be having doubt. So for that double checking, we can use this concept like this qubit entanglement and qubit manipulations to double check very fastly. And again, the above picture shows, like, in normal traditional computing, for input we'll be getting one output. So it's like slow process for searching and for storing information for anything. So it's like slow, we are getting only one way channel, but in this quantum computing we have so many ways channel for helping you search. And now coming to the applications of quantum computing, this is vast. Actually the applications are vast. These can be used in databases to search the information from the directory fastly using this qubit entanglement and qubit manipulation methods, because if we are searching for one thing, it will gather the information of the other thing at the same time. And if you don't need it, okay, no worry, you can take it when needed, because again it will be stored in the cache memory, for example shared cache memory, anything. So whenever you want, you can directly take from that, because it has already gathered the information. You need not to worry again and process the information for searching the information which you don't want. Like A you are focusing on, but it indirectly takes B, just an example. But you don't want the B at that time, but somehow you want that B in like x plus 1 time, sometime later x plus some y time. So at that time the B is already stored in the shared cache data. You can take directly without being processing any methods. Everything else, like nowadays the encryption has been done in the passwords for the user information in any websites or anywhere. So this can be actually fastly cracked using this quantum computers, because these can relate to lot of combinations in that password. So they can crack so many combination to find out what is actually encrypted inside that password documentary, so that your password can be hacked, easily cracked actually. But now traditional computers take a lot of time to crack those codes, because it's like very difficult code to crack. But this quantum computers, uh, using this again qubit entanglement and qubit manipulation, it take like seconds to crack it. So it is also having some enrichment in password encryption crack. Range of applications in medical field, like we can use in simulations of biomolecules. Like if you have so much like molecule, so you can actually determine the atom's positions to represent where the atom should be, so that it can help to nourish your problem or anything in that tissue, in the organ, so that it will be helping you find that and detect the diseases actually and the cause of that, so that you can actually act immediately on it. And again, because of its combination and fast responses in within no time, it can be used in various applications, like in teleporting and transferring information, navigation, etc etc, and also in uh, and again how it can nourish the tissue, how it can react to that vitamin and the protein inside the tissue of that organism. And so based on the applications of combination, it can infer to that uh, particle or the part of that tissue to nourish it and to develop some changes in it by applying some mechanisms to act on it and help to nourish it. And again, if the whole thing how it came actually from this theory of phenomena, quantum tunneling, as you can see in this picture. So we have famous quadratic equation, time dependent, time independent equation. So various v potential we have from regions actually. If you take right region to be first region and the middle to be second and left to be the third, anything you can take. And various potentials have been given, like right and left the potential is 0, and the potential in the nutshell you can take as v. So actually that electron can hit it and reflect it back, or it can exponentially go up above that nutshell, and it can pass through like transit. So that is like quantum tunneling. So based on that we form equations and we determine that electrons, like if we are keeping the transistor the size of atom in that nutshell place, so electron can simply transit from that transistor and go past that area. But this should not happen actually. Transistor is to it should be acting like switch. It has various application, but the one of the application is to act as a switch. So whenever the electrons like current is flowing through it, it should act as switch. Like if 0 is like down ground state and 1 is the excited state or above state. So if the current should pass through means it should be 1, and if it should not pass means 0. So based on these bits traditional computers. Actually, we are using bits. So based on this 0 and 1 only, transistor acts so that the electron can pass and can stop. But if electrons are simply transiting in this phenomena like of quantum tunneling, so whole process of the traditional computer will be gone past. And again, transistor should be small enough actually. So if transistor are small, means we can fit in a lot of transistors in a simple processor. So a lot of area can be saved, and lot of information and database methods can be computed. Lot of transistor means lot of computing, as described earlier. So the same thing, what we are using the quantum tunneling as an advantage in quantum computers by applying some magnetic fields, and again low cooling, like in low temperature we have to do all this computing stuff. And in quantum computers are like new computers, we can't reproduce it in our mobiles and computing which we have now. It should be very new. We are not regenerating it, we are actually replenishing it, like we are bringing it new actually to the market. So it can't be replaced in our traditional computer.